Hey guys, how's it going? I hope you're all doing all right. So, today we are going to be working on ECS and physics. How's it going, Langors? Good to see you. I'm not sure how long I'll be able to stream this time because I am coming down with something with my throat. So, I have no idea how long I'll be able to talk and stuff, but we'll see. And how's it going, Tree? Good to see you here too. So, basically, right now I have to fix a little bit with my ECS. It's not working properly. I believe it's just the view that's not working properly, so we'll have to fix that. But after we get that fixed, we can sort of move on to the physics, because once I have an ECS working, next logical step would be to code a system, right? So that is what we'll be doing. What we have so far in the Minecraft game is this. I also need to fix the fog. It's just way too thick right now. So I just really need to push that back a little bit, but you'll see that we don't really get any lag spikes and stuff. We do have some chunk errors and everything, and I'll have to do some more debugging for that stuff. But I think my main concern is getting some simple physics working, because once we have that working, it'll be a lot easier to sort of play test and everything. But yeah, will there be a stream tomorrow as well? I don't think there will be. I am busy tomorrow, but if I have some extra time in the morning, I might. So don't hold me to that though. But yeah, so basically this ECS isn't working properly, so I'm going to switch into debug mode first of all, which means it will be a little bit laggier and stuff, and then I'm going to put a breakpoint up here too, just so that we sort of stop there. But the way this works is, like I sort of explained in the last stream, we can create a bunch of entities. This will create entities 0 through 10, really, because if we look into this, all this is doing is right here, okay. So, or actually, that's the internal method. It's somewhere over here. Inside the registry. Okay, yeah, right here. So basically, it looks to see if we have any free entities, which are just something that we deleted. And then if not, it just emplaces a new one in the back, and then it gives us that ID. So we should get incrementing order, and we can actually test that too. Whoops. By checking inside of the world, we'll just sort of say entity ID equals this, and then we'll just look at that ID just to make sure that this is working as I expect it to. So we'll print this out very quickly, and we're also just gonna need the right hand side. And how's it going, Flare YouTube? It's good to see you. And yeah, SC Woods donated a lot of money. He's insane. So I'm really appreciative of him. Langors, does my ECS implementation add, remove registers the entity's components immediately, or only at each frame? So basically the way it works is you can add components, and that will add it immediately. So the way this works is basically we look into our component pools, which are just different arrays, right? It's just static arrays, and they have a maximum size right now too and stuff, but I'm not too worried about that. Basically it'll see if we already have an array for this. If we don't, it creates a default pool, which is just empty. And then otherwise we create it here. And then what we do is we just literally get the component at whatever this ID's index, or whatever this entity's index is, and then we zero that memory and we return it. So we do not wait till the end of the frame, which should be fine too, because the way we're going to be using this is through these views. And the way these views work is basically, we'll take a look at that in a minute too. So, but essentially these views should ensure that if you're adding, removing entities in the middle of the frame, it shouldn't mess up the view, and we should sort of just chug along, and we should be fine. So yeah. And Flare YouTube, Gabe, what physics engine are you using? We're making our own. So Minecraft is pretty simple. It's just cubes. So we should have a pretty good time just adding in some very simple physics, okay? I don't know if we're going to do rotated cubes and stuff, but I think that would be interesting to do at some point too. Yeah. And Langors, gotcha. Will be interesting to take a look at that. It will, yeah. So we'll take a look at that in a minute. For now, I do want to see if we're getting this right first of all too. So basically what I'm doing here is I'm just creating 10 entities just to sort of test everything. And then for 0 through 5, I'm giving those entities a transform component. 2 through 8 gets a rigid body, and then 5 through 10 gets a box collider. So we should have some of them, and I'm actually gonna make this 4 through 10, just so that we have one entity that has all 3. So basically these all intersect at different points, and we should get some entities with a little bit of each of these components. Okay, yeah. And these components are just dummy data right now. So yeah. And FlareTube, you just remembered one thing that has Minecraft. All the blocks has a random rotation, so they are varied. Yeah, I know that is something that we'll have to look into as well. It shouldn't be too hard to do because we can just like rotate the texture coordinates to get that type of thing. But there are some blocks that have a fixed rotation, like logs and stuff. So we want to work something out for that stuff too. Okay, but if we look at this, this is definitely a problem, first of all. So it says entity ID is 0 every time. That's not what it should be. I think it might be because I'm doing some bit shifting stuff. So if we look at this create entity thing one more time, what basically happens is, yeah, so we check the not free entities, and then we basically go in and we call this internal create entity, which uses our size and 0. So what this does is it says, oh, this is the index and this is the version. And then we shift the index left, and then we have the version as the ID. And the version is for if you delete entities and stuff. So what I might need to do is call this get entity version, because I believe this is going to return a 64-bit integer. So ID is a description. Okay, and so this description, yeah, has the ID and then a component mask. Okay, yeah, so this is a 64-bit integer. Okay, so that's all fine. Yeah, so I'm going to have to check out what's going on there real quick. We'll step through the code and see what's happening, because I think that's going to be the best way to debug this. And FlareTube, how do you edit write more than one line at once? You'll have to sort of explain a little bit more on that one. Okay, so if we go into here, we should hit that breakpoint. Okay, there we go. And if we go into here, so we have no free entities. And then if we call this function, basically we're going to create this entity description with size. And if we look at this, if we jump into there, that means we get index 0, version 0. Okay, so that's all good. And then if we just sort of finish that, then we push that back. Okay, so then on the next one, this should be different. Okay, so then we in place back. And thank you for subscribing, Lingors. Hey, that's awesome. So then this index is 1. Okay, so that's right. And then we get version. So that should be like 1 shifted left 32. So that's not going to be quite what I was expecting to, but we'll see. And tree, do you mean multiple cursors? If you will hold, oh, okay, yeah, I'll explain that in just a minute too. Okay, so that's different in different editors too, so it is a little bit weird. Okay, but basically this ID should be different. If we look at this, yeah, so we get a really big number because we shifted 1 left 32. Oh, and I think it's just because of the way I'm printing it. If we want to print a 64-bit integer, C print 64-bit integer. Yeah, I think we just need to do a UL or something like that. Let's see. Where's the C printf? Okay. No, not that one. I want the documentation. No, not C++. Oh, yep, this is it. Okay, cool. So U is an unsigned decimal or integer. That's not what we want. We're using D, which is a signed decimal integer. But I believe we need something else. Okay. Oh, yeah. So we just need to say like L. Okay. So DL, which should give us a, or DLL. I think long is double long. So if I just change this to this, then we should see what we're looking for. And yeah, I'll show the multiple cursors thing in a minute too. Okay. So if we do that, then we should get a different number. Nope, we're just getting 0LL. Okay, so I must have done that wrong still. So it looks like, yeah, it's saying like DI does this stuff. Let's see what their examples show. Oh, you have to do LD. It's kind of weird, but we'll try that in a minute. Okay. And sorry, LL is first, then D. Yeah, that's weird. Okay, I'll try that out. So we'll do that instead. Printf is weird. It surprises me every time I use it. Okay, so now if we go through that, we should see... Okay, there we go, yeah. So we are getting the proper things. I might have the version be the left 32 bits because I think that probably makes a little bit more sense than having like its ID be the left 32 bits. So I might change that up. But yeah, Flare YouTube, you asked how we can do multiple cursors. In Visual Studio, if you just hit Shift Alt and then you go like up or down arrows, you get multiple cursors. And they only work while you're in like one place. So if you start highlighting stuff, you can do that. I believe you can also just like click the scroll button. And no, that might be in IntelliJ where you can just hit the scroll button and drag, and then that'll select multiple cursors too. But yeah. And your friend gave up on creating your programming language. That is sad. One thing that I thought would be super cool, guys. So I've been watching Ben Eater a lot, and he does a lot of hardware stuff. And he uses 6502. I think that's like the CPU. I thought it'd be really cool to like create our own language in like a YouTube series one day, and then compile that language to 6502, and then create the hardboard, or yeah, like the breadboard and stuff, and like create our own circuits and everything, and then hook it up to like an LCD display, and then compile our programs, put it into the 6502, and then, or like some program, and then we can like basically run it on our own circuitry and stuff. I don't know. I think that'd be like an interesting project to do one day, but that's probably way in the future. Okay, so anyway, so this is working properly. What I'm going to do though, and that also explains why this isn't working, because I is not the correct ID at all. So I'm going to go into here and change this up a little bit. Actually, this is in the .h file. So yeah, instead of doing our create entity ID this way, I'm going to do the version shifted left 32 followed by our index, and then I'm going to have to change up some other stuff to accommodate this. So let's say this is shifted left 32, and we'll just have our index right here. So that should be good. And, oh, you guys are talking about IntelliJ and Eclipse and stuff. I like IntelliJ way better too. So yeah, Eclipse always gives me all sorts of problems. It's just never fun, but you know. Okay, so then if I just fix this by saying that should be ID, and actually we need to return entity index, so that should cast it to a 32-bit. So we just sort of drop off those lower bits or higher bits, and then this should just be shift right 32, and we no longer well, I guess we'll cast that still. Yeah, cool. So this is a uint32, this is a uint32. Okay, cool. So if we do that, I think that should be all we need. I'm just gonna double check real quickly to make sure I wasn't doing anything stupid. So and this will give you guys kind of a broad overview of how this works too. So this is the component IDs. That's just for generating a new ID for every different type of component. And then we have this is null thing, which is just like a uint32 max is a null entity. Yeah, so I have this declared here. And then you can see that the null entity is just uint32 max, so that we just use that last ID. I guess it would be nice to use 0 as that, just so you could say like if entity. But yeah, that doesn't really work out too well. So yeah. And SC Woods, good to see you. Why don't we just create an AI robot, backflips and whatnot? That'd be cool. Okay, so we've got these component pools and stuff. I'm going to skip that because what I changed shouldn't affect those. Okay, so the create entity, this should have some things that are affected, but I think that's fine. Yeah, it doesn't look bad. And we're using get version here, which is good because as long as we use those functions, we shouldn't have any problems. I'm just looking to see if I like used bit shift manually here, which would screw everything up. But it looks like I am good. Yep. Okay, cool. So I think we're good. And then if we run this one more time, then we should get like 0 through 10 here, since I've sort of switched the order of how we're using those. So if we just go through this loop real quickly, and I'll just remove that breakpoint. Okay. Yep, so then we get 0 through 9. Cool. So that's right. I mean, that is what I wanted. So now if we just continue on until we finish, let's see if this view works now, because I think it should be working properly now. Okay, so I'm viewing transform in rigid body, and we get entity 2, and we get entity 3 and entity 4, which that sounds right. So which entities have transform in rigid body? So that's 0 through 5 and 2 through 8. So where that intersects is 2 through 4, which is what we get here. Cool. Okay, so it looks like this is all working properly now, so we can sort of move on from this and just start working on physics. And you just saw a YouTube video talking of a robot taking backflips. Pretty insane tech. Was that a Boston Dynamics? Because if so, that might have been the Corridor crew guys who faked that video. But I don't know if there's another one though. That okay? Yep. So yeah, they're like VFX artists and stuff, but it's still cool to see how they made the video and everything. Yeah. But yeah, it is really, so like I believe they did, let's see. So like they do a bunch of VFX and everything. Yeah, and then you can sort of watch their breakdown of this stuff to see how they did it here. So but it's interesting. So you might want to check those out too. Okay, so it looks like our views are working and stuff though, but I'll show how the view works just so that you guys can see how. Yeah, and it was it was Boston Robotics versus Tesla Robots. Oh, okay, so maybe it was something else. That would be interesting. Wait, so let's see. Boston Robots versus Tesla. Oh, okay, cool. You might have to send me a link, and I'll have to check this out a little bit later. We'll have to see about this, because I'd be interested to see that, and I think some other people would too. Okay, but yeah, so it looks like this is all working properly. If we look into the actual view, like how this works, what ends up happening is quite complicated, but it's not too bad. So this basically takes in a template variable length args, and it ran an obstacle course. Yeah, I might want to see that link. That'd be cool. But basically we get this variable length template args, and then we pass in our registry to this thing called a registry view. And so what this object is it's basically takes in the registry, and then we basically get all the components. So if you pass in no components, it'll just view everything. So this will be like iterate through all my components and all my entities. Otherwise, if you have specific components, we initialize them here, and then this basically just unpacks that array. And then we loop through 1 through whatever that size is, and then we set it in our component bit mask, which is basically how we tell if an entity has a component or not. And then we create this iterator, which basically just uses the registry, an entity index, a mask, and whether or not we're iterating through everything. And what we do is we just return that entity for this iterator. We have like a little operator to tell whether 2 iterators are equal or not. And then when we do plus plus, what we do here, so this is sort of how we can iterate while we're adding or deleting stuff. We just keep incrementing our index while our index is less than our registry entity size, or we don't have a valid index. So basically we just keep going until we find another entity that has all the components we need. And the reason this works and we don't have to worry about like invalidating iterators or anything is because we just have a fixed size array right now. And so those entities will always occupy the same place in memory, and this should never really fail. So yeah, so if we add or delete stuff, we should not invalidate our view. Okay, but anyways, now that we have this working pretty good, I do want to add in a very simple physics thing. We'll just sort of get started and see how it works. And skip to minute 8. Okay, I will check this out after the stream because I'm interested to see this. Is it too hard to make a visual scripting language? It's pretty hard. If you're doing any sort of programming language stuff, there's lots of edge cases that you tend to miss, and it can get pretty difficult pretty fast. But yeah. Okay, so let's go ahead and create like a physics thing. So I'm going to have like a physics folder, and then we'll have another physics folder right here. And also, if you guys want that tutorial too, because there was a tutorial I followed for this, and I'm going to be changing it a little bit more, but it's this tutorial here, davidcolson.com. If you just type in ECS and C, it should pop up, and he does a really good tutorial here. So yeah, and then he talks about sparse sets, which is how you could speed things up and everything. But yeah, Good language equals hard. Piece of crap equals easy. Yeah, I guess that's true. Well, technically, I don't know. I think Python was made pretty quickly too. Like, how long did it take to make the first version of Python? I know JavaScript came out in like a weekend, but I'm pretty sure this was made pretty quickly too. I'm not completely sure. And I think that's one of the whole reasons they switched from like Python 2 to Python 3, just because of all the inconsistencies in the language and stuff. And so they were like, oh, we got to fix this. But yeah, it doesn't look like we got anything. Maybe I'm just thinking of JavaScript, which was made in like a weekend. So yeah. Okay, anyways, we got our physics here. Let's go ahead and create like a physics system, and then we'll have like a physics components so we can sort of include those. So this is my H. Easiest thing is physics components. And this will just have like all the different components you might ever need, which is like rigid body, that type of stuff. And I like separating this stuff out just because it's nice to be able to just include all the components you need. And this could be Minecraft, physics, components, H. Okay, there we go. So we'll do that, and then we'll say define that, and we'll do an end if. By the way, too, Flare YouTube, you made, bruh, Python is rubbish no matter what. Whoa, tree, that's not cool. And Flare YouTube, Gabe, do double ampersand and double or work in Java? Yeah, those work in Java. And you can also use bitwise operators too, which are just single ampersand and single pipe, which we'll do bitwise operators on that stuff. But Flare YouTube, you also asked about the multiple scrolling and stuff. If you guys don't already know, like your keyboard shortcuts in your editor, I would definitely suggest learning them because they make typing so much easier. Like if you've used Vim, you probably already know this, but like Control Shift Left will just select the whole word. And so you can do that. And if you do Shift Home, that selects like the whole line. And it's really nice knowing these keyboard shortcuts and stuff just because you can move around so much easier without having to use your mouse. So you guys should take a look at the keyboard shortcuts if you don't already know them. Okay, anyways, we'll have our namespace, Minecraft, and we will have inside of here a struct rigid body for now. So this will be for different entities, and then we'll also have a struct box bounds. I guess we'll call this box collider. And then we will, yeah, I think that should be good for now, right? Got our rigid body and our box collider. That's good. Okay, and then let's add another header inside of here. And this will just be our physics.h. And this will sort of be our physics system. So then we'll say hash if not defined, Minecraft physics h hash define hash end if. Okay, and then we'll have namespace Minecraft namespace physics. And since we are using ECS, it's really easy to create a function that will work for this. So we can literally just say something like void update, and this will take in a const. Well, we'll take in a registry because we don't know if that's gonna be const or not. Our registry, and then we will also take in, yeah, I think, oh, delta time. It's like I'm missing something there. Okay, so we'll take in our registry and our delta time, and we'll sort of fix our delta time so that it's a fixed time step for our physics, just because I like doing that. But yeah. Flare YouTube, how do you duplicate a line? Yeah, Control D works for that. So that should duplicate. It might be different in Visual Studio Code and stuff, because I know there's a few that always just throw me off because I'll start using my keyboard shortcuts and they're different, and that's always annoying. Okay, anyways, though, we will have inside of here like forward declared stuff. So if we go into ECS.h real quickly too, I think I have the registry. Okay, yeah, so we have ECS and we have an internal, and then we have registry defined inside the ECS. That's kind of annoying, but I'll keep it this way for now. I might change that in the future. But yeah, so anyways, what we'll do is we'll just say like class ECS registry. And actually, I think that's a struct. So let's just make sure we're defining that correctly. Just to forward declare it, and I might have to just do like namespace that, and then struct registry. Okay, so we forward declare that, and then we can use that forward declaration inside here. There we go. So we get no errors. And the reason I'm forward declaring these two is because it's so much easier on compile times and stuff if you make sure not to have multiple includes in your header files. If you want more information on that, there's a great little blog on our machinery, which I believe VoxelRiff showed me. And I think VoxelRiff showed this to me, but like, I love him for this because this blog is amazing. So if we go to like their blog and stuff, they've got, or at least they used to. Let's see, did they change things around a little bit? It looks like they did. Maybe it's in roadmap. Nope. Blog? Yeah. Okay, here we go. Yeah. So they just got like a list of all their stuff, and these people are insane. They're coding a really nice engine in C99, or at least all the header files are C99. And so you can just sort of follow their progress here, and they have a lot of good stuff in here. So if you're doing C++ and everything, definitely take a look at this stuff. And fatal errors in Java is a good thing, right? You really want lots of them. That's true. That's always the best thing to happen. Tree, they are good. You want to see them. Yeah. Okay, so we've got this forward declared and everything. But anyways, we have our update method. Let's also have like a void. Actually, we don't need to like add anything too, because since all of this stuff will just be inside of our ECS, we can just say registry.view, like transform rigid body, blah, blah, blah. And then it'll basically just give us all of our physics bodies, which is why ECS is nice too. So yeah. Fair YouTube, Gabe, can you please do a tutorial on how to create a web browser like Chrome or Microsoft Edge? I want to do my own because they are heavy. I have just 3 gigabytes of RAM. I wish I knew how to create a web browser. They are insane. But there's a very good tutorial I know of. Let's make our own browser. And it's super long. Yeah, I think this is it. Yep. So basically, he's doing this in Rust, I think, but he's got like 7 different parts, and it's really interesting. So I would say take a look at this. Limpet.net. Let's build a browser engine. I've been wanting to follow this for a while, but I haven't. It looks really interesting though, and there's a much bigger in-depth about how browser engines work and stuff, because they are pretty complex stuff. So yeah. Okay, so we've got this update, which should be good. And I think this is all we're going to need, really. So I'll just leave it at this for now. Let's also go ahead and... where should transform live? Because that's like a core thing, right? But I have no idea what system takes a transform, right? Because that's just sort of like everything. So I think what I'm going to do is I'm just going to have a new item, and we'll just call this components.h, and this will be sort of like our engine's base components that aren't really tied to any system. So we'll just call this Minecraft components h, and then I'll say define that, and then we'll say end if, and we'll go namespace Minecraft, and we'll have a struct in here, transform. What is a struct going to have? It's going to have a glom vec3 position, and then we can forward declare that, I believe, by just saying like namespace glm struct. Actually, no, we don't need to forward declare this, because whoops, we have that in core. So we'll just include core.h. Okay, so we got vec3 position. We'll have a scale, I guess. Yeah, we'll do a scale. And do we want rotation and stuff right now? I'm going to say for now, no. Well, actually, we do need a rotation. How are we doing it inside of our player controller real quickly? Let's take a look at that, because that's sort of where this stuff is happening. So if we look at player controller.cpp, we basically have our position, our speed, and then we have the camera, and I believe the camera is where this is happening. Okay, so we basically just have a forward vector, and I guess that's how we're using, oh wait, no, we do have a glm vec3 orientation. Okay, we'll do this for now. I might upgrade that to like an actual quaternion in the future, because that is technically what you should be using, but this is good for now. Okay, anyways, so we've got all this stuff. We should be good. Now if we go into physics.cpp, actually, we didn't implement that yet, so let's go ahead and we'll make a physics.cpp class, or a file. So physics.cpp. This will include physics/physics.h, namespace physics, and then we have that void update ECS registry reference registry and our float delta time. Okay, and then we'll say include ECS, or I guess that's in core / ECS. Okay, so, oh, and this should be in Minecraft. And then namespace physics, and we should be good. Okay, and it's complaining about this. I spelled it wrong. There we go. Cool. So now we're good. And is ECS superior to component architecture? Yeah, and quaternions break my brain too, Flare YouTube. But ECS is, I think it's better than component architecture, because basically what ends up happening. So if we take a look here, I go over this a little bit in my ECS video on the game engine series too, but I use the component architecture for Java just because it makes a little bit more sense in Java. But basically, like in ECS, what ends up happening is you just have a bunch of different component pools. So this would be like your transform. This would be your rigid body. And so what ends up happening is like you just have all these lined up right next to in memory, ideally. And so then when you're iterating through all your transform and rigid body components, your CPU will fetch a big block of this, depending on how much memory you have. So it'll put this in the L1 cache. And the reason that's good is because since this is all in the cache already, once you move to the next component, you won't be skipping large amounts of memory. Whereas with the component architecture, at least in the game engine series, you basically have like a game object, and then this has a bunch of components, and then you have another game object, and this has a bunch of different components, and so on. And what ends up happening is the CPU has to like go from here, and then once it goes to the next game object, it skips a lot of stuff depending on how many components this has. And so then this will not be loaded inside of the L1 cache already, and so you won't get as good a performance. But as with all things, you should probably not optimize until you are aware of like a problem and you know you need to make things faster. But yeah. I've been preferring ECS more and more as I've just coded a little bit more too. So it's preference too. But yeah. Okay, so inside of here, what we'll do is we'll basically say for entity, I think it's just ID, entity in registry.view. Did I spell that wrong again? Registry.view. Okay, I think it's just because I have to prefix that. So ECS entity ID dot view. That should work. What's this saying? Registry is undefined. Oh, I spelled it wrong up here too. Okay, there we go. And then we can say view, transform, rigid body, and box collider. And this will give us all of our entities with those components. So then we'll say include physics / physics components. And we'll also include core / components. Okay, cool. So we're going to loop through all these. And then for now, what we're going to do is like the simplest form of what you could do, I guess. This is also a good, we're probably going to need like a reference to the world in here somehow, or like some way to get to the world just so that we can tell like what block we're next to. So trying to think, I think the world should probably just be a singleton, so we can basically just access the world from anywhere, because that is sort of what the world is, right? It's just one big thing. So that's probably how I'll model it. So let's go close out some of these real quickly. Okay. And then inside of world.h, we'll have like a function which is get block or something like that. So this will return like a block, and this will be get block. And we'll take in a ivec2 position. This will be a world position, and we'll actually just take in a vec2 or a vec3, and then we'll sort of figure out which block this is and return it from there. But yeah. And Langors, how do you handle colliders from ECS perspective? Do you have a base collider, or each collider has its own hierarchy? Also, what happens if you add colliders of different type? I'll talk about that in a minute. And Flare YouTube, SE Woods or Gabe, do you know any Unreal Engine 4 or 5 tutorials? You want to make FPS game, but I can't find a tutorial about that. Yeah, so the only one I know is like $12, but if you go to Udemy, Unreal Engine, there's a really good tutorial by a couple of guys. I think it's Ben Tristram. And I know it's $12, but like seriously, yeah, it's this one. You will not get a better tutorial than this. Okay, whoa, it's $109 now. So wait for this to go on sale and then get it, because that's when you should. I got it for like $12, not that much, but it is really good. And the guys teaching it are very good. Yeah, Ben Tristram and then a few other people. So if that goes on sale, I would say grab that. Yeah, $100. If only there was a Brackeys for Unreal. Yes. Well, that's what I feel like Ben Tristram is, but not for $100. So I would say just wait on that, because it'll probably drop eventually. Okay, so we'll have this block, get block, and I believe we're already doing this sort of. Are we? No, I don't think we have any sort of way to do this yet. Do we have this in chunk.h though? Because that might be helpful. We have all this stuff. Okay, we do not. So we'll add a function in here too, which is block, get block. And this will just return a block based on like a GLM IVEC3 position. And then this will sort of do everything for us too. Okay, cool. So we'll do that, and then we'll say chunk.cpp. And we'll go into here, and we can just use this stuff to do that. I think I already have something. Yeah, so we do have a get block function. Yeah. Okay, so this is going to be different than this one, but we can use it still. Okay, and now this one, yeah, this is going to be mad at me. So I'm going to have to change the name of that one in just a second. So this will be get block internal. And we'll use this to figure things out for us. So yeah, actually, we can just keep this. Well, yeah, we'll call it internal. But yeah, and we'll do it this way. Okay, this works fine. So then we'll just change all of these to get block internal. To fix those up, fix that and these ones. Okay, and then we have this get block function, and what this will do is it just says get block internal, and we'll pass it our data, which I believe is just called data. I might have to change that, and then position.x, position.y, position.z. And if we look inside of chunk.h, it's called chunk data. And I also have to prefix this with chunk, and this should be chunk data. Okay, cool. So that should be that. And then inside of the world, we just want it to do the same thing, except we have to find the appropriate chunk first. So we'll say world position. To clamp that to a chunk, we could just say glm ivec3 chunk position equals world position over 16. So we'll just do like world position times 1.0 over 16, which should do what we want. And this will basically just clamp it to some integers, and that should give us the chunk. And then we need a way to get the chunk too, which I think I'm doing somewhere in here. So let's look where I'm doing that. Okay, yeah, so I basically have this player position, chunk chords. And then we go through all this stuff, and local chunk position. Okay, and then okay, so then we just have this like chunk coordinates thing. Okay, I don't think I have anything that's specifically for this. I think I have a find chunk function somewhere in here. Nope, maybe I got rid of that too. Okay, we'll make a find chunk and everything in here too. SE Woods, the Boston Dynamics video reminded you of a movie called Ex Machina. And as we in an earlier stream talked about movies being recorded in Norway, this entire movie is recorded in a hotel out in the woods in Norway. That's pretty cool. I did not know that. That's Ex Machina. I'm thinking of Machinist. That's a different one. But Ex Machina is like the robot one. I think I've seen some previews for that and stuff too. But yeah. I think I'm going to probably have to end this stream pretty soon, guys. I know I just didn't get anything done, but I just have not been feeling very well lately. So yeah, I'm probably just gonna end the stream here. We'll continue the physics and stuff the next time. Hopefully I'll be feeling better and stuff too, so that I can go on for longer. But I do appreciate you all coming out to see the stream today. And I might work on this in my off time, but I might not too. So we could probably finish this up. What am I feeling? Well, like it's like a bad cold. So I'm just like slightly feverish, and then I've got some throat stuff going on, which is getting a little bit worse, but it's not bad. But it does make working a little bit worse. And thank you. I appreciate that. But yeah, we will continue this though. And hopefully we'll have working physics pretty soon, guys. So yeah, thanks for coming out again, guys. And I hope you enjoyed this, and I'll see you guys next time. All right.